Thank you. Hello with everybody. Can you hear me? Yes. So like many of yours or some of you, I also used the traditional analysis approaches to estimate parameter values and then to feed more complex models to analyze to analyze different management scenarios. Just to finish the... too much hair. That's a sea turtle. Okay. Sorry. Better? Okay. So my case example is on a small-scale lobster fishery that is happening in an area at the northern coast of Ecuador. This area was declared as a marine reserve 5 years ago. During the process of declaration of the area, the local fishermen already manifested their concern about the state of the population of this lobster. So together with them, we registered the catch of the fisheries and also took some effort and length frequency data between November 2009 and August 2010. Those were all the available data. So by then, what we did was a very, very simple analysis of this data. We didn't have the time or the resources or the knowledge to apply a model. So the analysis that I'm going to show you here was done afterwards, and I use this for learning about this experience through modeling and for applying these lessons for the future. So with those available data, one thing that I wanted to tell you is that in that moment when we were working with the fishermen, there were some available funds and there was the urge to implement some management action. So we sat together with the fishermen and analyzed their options, and we had to take a decision. We took a decision, I will tell you later. With the available data, what we did was use the typical fisheries analysis to estimate the growth parameters and the population parameters, such as natural and fisheries mortality, length at age, probability of capture. And we also did a virtual population analysis which back calculates the size of the population. And for future estimations of the yield and the stock of the biomass, we did a yield per recruit analysis. So with this, we could answer our questions and the fishermen's questions to what is the actual level of fishing mortality, what is its position with respect to the optimum fishing mortality, and is the lobster stock overexploited? With the results of this fisheries analysis, we input the population viability analysis, which was implemented in Vortex. Vortex is an individual-based simulation model that models a population, or that simulates a population going or stepping through these discrete sequential events that happened with certain probabilities. These probabilities can be modeled as constant, or they can be random variations that follow distributions. Vortex has been used to evaluate the conservation status of endangered species, to analyze the relative importance of population parameters, to test management scenarios, and to assess the risk of extinction or explosion of populations. With this method, we wanted to see what is the probability of survival of this lobster population under the current exploitation rate? And if needed, what would be the most effective management actions? Both methods have assumptions, and maybe the most relevant assumption for the fisheries analysis method is that the recruitment is completely independent from the SSB, from the state of the mature adults. Whereas in the population viability analysis, the recruitment is completely dependent on the state of the mature population, but the potential of or the amount of eggs produced by the females is independent of their size. The real thing is somewhere in the middle of those. Here in orange, you see the distribution of the green spiny lobster, and the eggs are released at the coast, and then they go into a pelagic phase for 9 months. Within this period of time, these little lobsters can travel up to 4,000 kilometers. And just as a reference, between Galapagos and mainland Ecuador are 1,000 kilometers. So the dynamics here are really working as a meta-population. But for this example and for improving the understanding of the population dynamics, we thought it was acceptable to take this assumption and model this as a single population. So the fisheries results say that the fishing mortality in this population was 3 times larger than the natural mortality. And that returns an exploitation rate higher than the accepted reference point of 0.5, after which a population is categorized as overexploited. The yield per recruit model says that the fishing mortality relative to the fishing effort that is currently done, and that here is represented by the dashed line, is way over the point where the yield reaches the maximum and where the biomass has decreased already by half. So the fishing effort should be reduced to also maximize the economic gain in this fishery. So now remember that the other results, so the growth parameters and other population parameters calculated with this method were used to input the population viability analysis. But we had a lot of uncertainty in the level of recruitment. So what we did is see the response of the population size with varying levels of recruitment that were in the range of what was reported in the literature for another similar species. And what we see is that the more recruitment, the faster the population growth. Now, for showing you what the results of the management scenarios, I will take as a base scenario a very low recruitment, which is there, is the same as the graph before. And in this lower graph, what I show you is the frequency distribution of the age classes after 10 years in this population. And what we see is that under this base scenario, the frequency of the individuals that are at the exploitable age class or larger is very, very low. So this was not enough to maintain a fishery. And now, thinking again on the fishermen that we were working with. We say, okay, what do you think? What are your options for managing this or for recovering this overexploited population of lobsters? And they said, well, Sole, we could maybe begin by actually respecting the national fisheries regulations. Okay, good idea. So our first scenario was to include in this model the response of the population size towards a decreasing fisheries mortality by releasing the undersized lobsters that were incidentally catched in the net. And what we have then is that the population actually grows and that the frequency of larger individuals doubles. For the next scenario, we added the enforcement of the prohibition of catching egged females. Then the population grows even faster. The amount of larger individuals is not increasing, but there are some even older or larger individuals increasing the potential of having more eggs. And on the discussion table with the fishermen, there was also the option of completely closing the fishery. And there we had the highest population growth, also the highest frequency of individuals in the higher sizes, and individuals grew much, much older. We can put these results in a color code and do a traffic analysis to contribute to the discussion of what could be the most effective management, effective and applicable management action, together with other aspects such as social, economics, political things. In this case, the only option that they had was to really close the fishery, at least for a time, until it recovered, if we wanted to keep fishing lobsters in the future. Now this requires a lot of effort and resources. At this time, we had the great opportunity that we could apply a conservation agreement with the fishermen, by which they could create a no-take area within the marine reserve and replace their fishing activities by monitoring their population and by doing outreach activities. So at the beginning it was great. And then just after a year, the conservation agreement had to be closed, mainly because of social pressure from other fishermen and other communities that saw that the lobster population was really, really recovering. So everybody wanted to have lobsters again. What I learned from this modeling process after having the experience in practice was, first of all, that in Ecuador at least we need to gather better data about recruitment. That is really, really important. We need to have realistic or a little bit more realistic estimates and learn how to deal with the uncertainty, and include the relation between the female size and the potential of producing more eggs to make a more realistic biomass calculation. For sure, we have to go to a meta-population analysis to capture better the dynamics of this species and get information on dispersal rate and maybe also on how is the state of the population in the region, in the other places in the region. And if we want to plan and make fisheries regulations for these species, we should think in a regional scale. Thank you very much.